If you have parts as complex as, say, in this case, an 18-inch steel drill bit, you need the power of automation that's available within Creo Parametric and Creo NC. So I'm going to take that model, let's bring it inside of Creo NC, let's put a workpiece around it. So now I know what I'm starting with, where I'm getting to, but rather than the usual pick a toolpath, pick a roughing, pick a drilling, and so forth, I'm going to say from templates. I do these parts all the time. They're all different shapes, but for example, in this way, I say I usually rough it with a large ball and mill, I re-rough it with a smaller ball and mill. Whatever your strategy is, you can store these as templates and reuse them over and over for each new job. So here, quite literally in a matter of minutes, I've developed a complete roughing, re-roughing, and secondary re-roughing toolpath to completely hog out the top of this part. Let's go ahead and play it in the simulation so you can kind of see. The real key though is these templates are not something predefined by the system. These are your strategies. You do it once and say, this is how I like to do steel bits, and let's store that. It couldn't possibly be easier, and then the speed benefits you get in manufacturing are really what everybody's looking at. So not only applying standards, but let's actually look for standard features inside of this model. And again, not system-defined standard feature. These are yours. These are, in this case, the pockets for all of these insert cutters, the holes for the nozzles that go down in the center of the bit. If you do that once, you store it, and then you can even store them as part of the design information. So here in real time, this takes about 4 minutes, but in 4 minutes it's built, I think it was 161 toolpaths. And that's the kind of productivity you need to be able to get these parts out fast to meet customer deadlines. So here you can see there's all these different toolpaths. Once I build them, I can play them, I can do anything I want. Here, for example, this is the peg drilling for each of the 640 insert holes. You can see I didn't have to pick geometry. Let the system go do it. Once they're built, these are toolpaths, just as if I'd have built them myself, picking one at a time, whatever. I can go in and change them, a different tool, different strategy, maybe change a linking between one area to another, whatever I need to do for this particular job. But the bulk of the work is already done, and that's what you really want to have happen. Here, I'll go ahead and play the intermediate part here. There's the drilling out of each of the pocket, the insert holes, maybe the center drill, the drill for all of the nozzles that go through the center of this part. Fast, easy, and best of all, they're my strategies. There's nothing predefined here. It's just something I go do. So that's all great. Let me show you how this works. So let's back up. Let's call up an existing model. And that's where it usually starts. It starts in manufacturing. And you say, I have a toolpath I want to repeat. So in this case, I'm just going to build from scratch a roughing toolpath. I'll put a window around it to say I want to constrain it. I'll set a depth for that window and so forth. So now I've got the geometry. I want to machine everything inside of this particular boundary. And once I've done that, I'll go ahead and say, let's do a roughing toolpath. So I simply say select roughing, pick a tool, pick a strategy. Again, just more manual building it. I've got it. I can play that toolpath. I can look at here's all the different parameters, the different ways to cut that we have for roughing. I'll play that toolpath and say, yeah, that looks good. No, I need to make a change and so forth. But the idea is you just build any toolpath, and then once you've built it, you can make a template out of it. There's no programming, there's no system admin or anything. So you could have that roughing, you could add a re-rough, another re-rough, whatever, but then you simply look at your list of toolpaths. In this case, I'll just pick this one roughing toolpath, and I say, create a template. That's all there is to it. You give it a name. If you have multiple toolpaths, you can say which priority, which ones comes out first, and that's it. And then you just say for any new job, a totally new part tomorrow, insert from template. And that way you've made up your library, but again, it's your library, and I can't stress that enough. It's not some feature recognition that we do. It's you say, you go do it. Now even better is things that you do all the time, individual types of features. So for example, these pockets you saw me do earlier, I'm just going to manually build in this case, let's put a center drill, for example, and then maybe come in with a peck drilling operation to actually do that. And you'll notice I'm only picking one particular hole. I'm just going to say, grab this tool, do this one hole, use these feeds and speeds, and then once I have that, then I store it. In this case, I need a peck depth operation, so there's a good drill toolpath. So now I've got 2 of them, and again, you could be 50 toolpaths. There's no limitation there. But once you have it, now you say store those 2, the center drill and the drill, store those as a template. Again, you can define the order. I always want a center drill first, then I drill, then I ream, whatever it is you do. But give it a name, they're my 640 insert templates, so forth. So now you've defined these XML templates that you can use in manufacturing, but even better, let's go back to the design world. So I'm going to put on my designer hat. So I'm actually making up this new bit, and here's these pockets that I want to do. So the way this works is you actually add an annotation feature in the design model. Here's the start surface, here's the drill surface, and so forth. So it's very fast, it's very easy. Pick a curve, whatever features you needed to actually do that. So now I've got that annotation in there, and that will show up when I do the extract steps. But is it reasonable to have your designer doing that all the time? No, the designer doesn't care, doesn't even want to care how this part's going to be made. But the designer quite often uses user-defined features to build this geometry. So that's what I'm going to do now. I'm going to use my standard design method of building this geometry. And we've had this for 20 years. But what we can now do is say, all right, build that standard geometry as part of your design world, but don't just include cut, rounds, extrudes, and so forth. Put that annotation in behind it. No picks, no real effort on the designer. He just simply says, go get my standard geometry pieces, bring them in. Once he's done that, if I open that part up in manufacturing, notice what we can do. So there's those 2 holes. Again, it knows that embedded inside of here are those 2 notations, the annotations that I put in there. All I have to do is, and it's that fast, just say extract, and there's a drill, there's a center drill, there's a ream, whatever you put into. So no extra work on the designer and no extra work on the manufacturing, and you absolutely get your part done fast.